Once again, just to reiterate, when we discuss about PBN, our focus is only the lateral separation and not the altitude at which the aircraft flies. We can specify an altitude or height for the air corridor. Altitude is measured with a barometric altimeter, which measures altitude using atmospheric pressure. Height is measured by a radio altimeter or Rnav. These two equipment would ensure that aircraft sticks to or maintains the prescribed altitude, and that is why our current focus with PBN is lateral separation. It is not only about prescribing or setting an air corridor, but it is also important to make sure that the aircraft stays within that space, does not drift away from the lateral space it was allotted. How can we make sure of that? Say an aircraft is traveling from A to B. We set an airway for this aircraft. As you can see from the visual, these two lines represent the airway for this aircraft between departure point A and destination point B. Having defined this airway, pilot of this aircraft needs to make sure that the aircraft sticks to this path within the allowed level of deviation to avoid this aircraft going dangerously close to other aircraft by drifting away from this path. Let us see how that is achieved, or what is the navigation system that helps pilots to achieve this. To achieve this, we install two beacons A and B at the start and at the destination. The beacons are ground-based navigation aids like VOR DME, NDBs, Doppler, etc. The aircraft should follow the range of these beacons at all times to stay within the allotted airway. Aircraft are equipped with instruments which can receive signals from these beacons. These beacons emit signals that the aircraft can tune into. As long as the aircraft remains within the range of the beacon, we can be sure that the aircraft is within the airway, which is known as ATS route or Air Traffic Service route. So, when aircraft starts from A, it tunes into signals from A and makes sure that it is always within its range. But as it moves from A to B, the signal strength from A decreases and it slowly gets into the coverage area of beacon B. As the aircraft moves closer to B, the signal strength from B gets stronger. So, after a certain distance, the aircraft disconnects from A and tunes into B instead. To summarize, aircraft stays within the range of beacon A until a certain distance, after which it tunes to beacon B. But look at the points where the ranges of A and B intersect. They are outside the airway. So if an aircraft follows the range of the beacons at some point, the pilots might think that they are flying within the airway, when in reality they are well outside it. This is dangerous as this amounts to violation of allotted airway and not an acceptable situation. We definitely have to avoid this. This is the precursor of area navigation, which is popularly known as RNAV.